have one question from the audience, which is it's from Deepak. How does the data, how is data collected as we will not be running any practical physical cases? Since we are only simulating in virtual environments, how is data collected? Like probably if you can give an idea of how it's happening in the industry and how what are we replicating and what are we trying to do? So would be great.
Yeah. So, I mean, if you look at simulation models, like you can look at a bunch of papers, but depending on the application, these days simulation models have come to a point where you get pretty good accuracies with them compared to real world testing. So, I of course was working on some of these applications at GT, and for some of these applications, we saw accuracies of over 95%. Now, when it comes to collecting data, for example, let's say you want to collect real world physical data for battery aging while in storage, right? So think about it. So you take a battery, you put it in storage, and by the time it ages, it takes years. Right, by the time you can actually collect physical data. So say you want enough data for a machine learning algorithm, right? So you might want to put it in different temperatures. You might want to put it in different humidity or atmospheric conditions. And you might decide to do this with 1,000 batteries or 1,500 batteries and let them sit for, say, 4 or 5 years, right? That's not feasible from the perspective of the industry, right? They want something fast. So that's the reason we're testing this approach, where it's a research project, right? So what we're trying to test is, instead of actually physically testing, let's take a simulation approach. Can we, we can easily simulate 1,000 different scenarios very quickly in a short amount of time, right? So the approach we're taking is, let's use simulation, a calibrated simulation model to get as much accuracy as possible. And once we have that, let's use that to collect data, and then let's build a machine learning model that can, fit that data pretty well. And this machine learning model could actually be used to, productionize it or go into a real world environment. So that's what we're trying to evaluate in the first two projects.
Yeah. One of that was, thank you so much, Anirudh. That was really helpful, guys. One of the things that you need to understand is what is that particular project doing? So in project 1 and 2, you're essentially building a machine learning algorithm, right, to predict battery age while in storage. So the end goal is to build that algorithm, right? Now, to build an algorithm, to build a machine learning algorithm, you need data. So data can either be simulated, data can or kind of can be taken from physical environments. Irrespective of where you take data, the most important thing is the end goal, which is how the algorithm predicts the battery age, right? So once you build the algorithm that predicts accurately with simulated data, you can be confident enough to say the same algorithm will also predict and make adjustments to even real life data, right? So it's the algorithm that you're developing, and for that, it does not matter how where you get the data. So I might be wrong in this, but what do you think, Anirudh, on that?
Yeah, I think, Surya, from one angle, you are correct that, it doesn't absolutely matter where the data comes from as long as it's representative of a physical system. But, the approach that I'm talking about actually is that we're trying to basically come up with a new simulation plus ML approach, right? That's what we're trying to propose. Because if you take a project to an industry and, tell them, collect a data for 5 years and, let's do this, that's never going to happen. It'll never see the light of the day, right? Because they want to deliver products in 2 years, 3 years. So what we're trying to do is basically propose an approach where you can combine simulation with ML and get to actionable results very quickly, right? Or at least results that point you in the right direction very quickly for engineering. That's the intention that we're trying to convey here.
Great. What will be the future of ML and AI in automotive industry once level 5 autonomous vehicle is developed, and once it is level 5 is developed, and what disciplines will ML and AI kind of come in?
Yeah. Yeah. So, I mean, the biggest thing that I see is connected cars, right? I mean, the industry is huge. I work in this industry, and the amount of data that we're collecting, now is huge. Like we collect, I can't, talk about how much, but exactly, they are confidential figures, but then we're collecting huge amount of data. And as more and more vehicles are becoming connected, the things that you can, these services that you can offer your consumers with this data is also becoming immense, right? So for example, the vehicle is no longer just a product that you use for driving, right? It's basically some tech product or a tech gadget with wheels, right? You can personalize your vehicle. For example, the moment you sit in the vehicle, it uses ML algorithms to figure out that you are in the vehicle. It basically sets up the interface, or it's the way you like to drive it based on who's sitting there, or based on information is collected about you in the past, right? Based on data is collected about you in the past. You have infotainment systems in the vehicle, and these infotainment systems can be configured specific to each user. And again, that comes from data analysis and understanding user behavior over the past. There's also the physics aspect of it. For example, if you have information where vehicles are communicating with each other, right? So if you can understand how vehicles are separated apart on the road, what environment is one vehicle going through, that information can be transferred to other vehicles, and then you can have ML algorithms to basically try and optimize how they should behave on the road, to save fuel economy, to improve battery range, and all sorts of things. So there are many applications, and the industry is growing at an extreme rate, and that's thanks to basically the concept where a vehicle is no longer just a car; it's a gadget on wheels, right? It's becoming a service that's being offered to a consumer.
Yeah, and the industry is probably in its nascent stage. And as you kind of get into more and more data, you will realize that uh, even things that we have not thought about will
Yeah.
kind of come in, and anything that you can think can happen and will happen over a period of time. And so there's no stoppage out there. In which autonomous companies or industries do mechanical engineering graduates, especially freshers, have job opportunity in ML, in AI, and other trending domains? This
Yeah.
from Pranav.
So to add to, I mean, yeah. So basically, to answer that question, so autonomous vehicles is just one, small subset of what you can do with ML and AI in the automotive industry, right? So I will say, just to be open out there, if it comes to autonomous vehicles, as a fresher, you probably don't have many opportunities because it requires some level of applied research. The phase where we are at with autonomous vehicles is in a very nascent research phase. But when it comes to applied machine learning or applied data science, that is with connected cars, right? When it comes to things like this, there are immense opportunities in most OEMs globally. I mean, I know for a fact that most OEMs, local and global OEMs in India, are working on connected cars and ML and AI projects with connected cars, and also physics-based projects that cover ML and AI. For example, battery aging. Right. So this is a physical phenomenon that you want to model with machine learning. So there are many opportunities in this space that are open for freshers and experienced people with 2 to 4 years experience to take up.
Can ML be used for vehicle dynamics applications, say for active suspension?
Yeah. So that was actually my master's thesis. So yeah, for sure. I mean, adaptive suspensions. These days, some of them have versions or concepts where machine learning is used to optimize suspension behavior when it faces certain situations. So yeah, for sure. ML is used also for vehicle dynamics.
Follow the pathway of, hey, the connected cars or the autonomous vehicles or electric vehicles in India is not a market that has opened up. How do we kind of get fresher roles? The reason that you think the market is not opened up is because you do not see those cars on road. But the OEMs, which is the companies that are developing these cars, are actively working on those cars so that in the next 2 to 3 years, they can have those cars in the road, right? So it's the perception of not having a car on the road might feel that, okay, there are no opportunities, but there are so many opportunities in the back end that's been kind of left open. Like we speak to a lot of companies, and say for example Mercedes-Benz, Ashok Leyland, and some of the best companies in these domains, and we know that personally all of these companies are working on aspects like ADAS or automated driver assisted system have a very good understanding, are looking for people who have very good understanding in, say, machine learning for automotive applications and applied machine learning and AI, building machine learning algorithms, mechanical engineers, automotive engineers having those experiences. So, and our motivation to kind of work on these kind of research programs is because we believe this is really, really useful for people to kind of build a portfolio for themselves when they kind of go into kind of this particular domain.